Right, I'm just going to quickly show you something called Lenz's law. Now, Lenz's law is another way of predicting the direction of the current, this time in a coil. So Fleming's right-hand rule can predict the direction of the induced current in a straight wire, but this helps us predict the direction of the conventional current in a coil. Right? Now, I'm going to show you. Let's use the strong magnets because we get a good current. So there's our solenoid. Okay. Now, when I pass the magnet into the coil, it induces a current in the coil. Right? Now, if a current is passing through this coil will itself also become a magnet. It will become an electromagnet. Now, there's something called Lenz's law, which says that when a north pole comes in, a north pole is produced here. So if this is an electromagnet, this end will be a north and this end will be a south. Lenz's law also says if a north pole leaves, then this end will be a south pole and this end will be the north. Now let me show you that in action. Right, so let's put the north pole in. So north pole goes in, we get a negative current. If we get a negative current, we're going into black. If we're going into black, we're coming out. So there you go. We're going to use the right hand, remember the right hand grip rule for a solenoid, for an electromagnet. If the conventional current is going in that direction, the thumb points to the north pole. So that's saying that if we bring a north pole in, this end will be a north. Now the reason is because the magnetic field of this is so that it opposes the change that caused it. So if a north pole comes in, there'll be a north pole trying to repel it. Makes sense? Well, let's say, what if the north pole goes out? So same north pole. If the north pole leaves, we get a positive current. Positive current is going into red. If it's going into red, it's coming out here. If it's going into red, then the conventional current in the coil, right hand grip rule, the thumb is pointing to the north pole. So that means there's a north pole there and a south pole there if a north pole is leaving the coil. And again, this magnetic field here is opposing the change that caused it. So if a north pole is leaving, there'll be a south pole trying to attract it back. It's opposing the change that caused it. Well, let's just quickly check that with the south pole. South pole going in. Okay, south pole going in, positive current. Positive current means we're going into red. If we're going into red, the conventional current is going like that, meaning that's a north. So if a south pole goes in, then there's a south pole there. Again, it's opposing the change that caused it. And finally, if a south pole comes out, we're getting a negative current. If we're getting a negative current, we're going into black. If we're going into black, just have a look there, then the current is coming over in that direction. So there you go, there's your conventional current. The thumb points to the north pole. So it means that that's a north and that's a south. So if there's a south pole leaving, there's a north pole here because it's opposing the change that caused it. Right, that is called Lenz's law. Thank you very much.